Ready, Jennifer. Now let's find out how surface area affects drag.
Your teacher will give each group a copy of the disc patterns from the lesson guide. Select and construct 5 discs. Look at one of the discs. What do you think the area is? Make a prediction and write it down. Now, calculate the actual area. What is the difference between your prediction and the actual area? Are you close? Repeat these steps for each disc. Before beginning the experiment, construct the test track. Choose any disc and place it on the front of the test vehicle like this. Place the vehicles on the start line. Make sure the string is nice and tight. Predict the distance that the test vehicle will travel when the fan is turned on, and write it down.
I predict it'll travel about 42 centimeters.
I predict it'll travel 50 centimeters.
Turn the fan on high for approximately 10 seconds. This is only a suggested time. Your time will depend on the fan speed and test vehicles. Now, measure the distance that the test vehicle moves backward and record it on the data sheet. Calculate the difference between the predicted distance and the actual distance and record your answer. How did you do? Now, test the other discs.
Now that we've gathered our data, let's create a graph that shows the relationship between frontal surface area and distance. Could I have one member of each group to come up and graph their data? Great job, guys. Let's look at the graph and answer some questions. What kind of graph is it? Do you see a correlation? If so, what kind is it? Which surface area produced the least amount of drag? Now let's put it all together. Look at the data from the first experiment you did. Which shape had the least amount of drag?
Tetrahedron.
This shape? Now look at your data from the second experiment we did on surface area. What did you find out about the surface area and drag? Based on your results, which of these 4 tetrahedrons should have the least amount of drag? How can we test your predictions?
Put the shapes on the drag stand and see what happens.
Great, let's do it.
We'd like to thank the AIAA student mentors from North Carolina State University.